My name is Billy Holt, and this is my honors chemistry project on fingerprint similarity and fingerprinting similarity. Let's just dive into it. This is the background of fingerprints and fingerprinting. Um, First of all, fingerprinting is the process of identification based on the impressions of the culminations of the fingers. So it's just the process of identification of like your fingerprints, the patterns on your fingers. Um, Fingerprints are used currently for mainly identification, in the investigation of crimes, and also just to unlock your phone, which is pretty cool. It's really developed. Um, One's fingerprint is so like important and expedient because no two persons are identical. So no two people have the same fingerprint, which means it's almost like a DNA sample. Like it's a really good way to identify people. Um, and before the development of fingerprinting, people identify criminals by just putting like a brand on them or like putting a mark on them so everyone knew. So this is a pretty big leap discovering the fingerprinting. Um, Fingerprinting became the scientific method of identification in the 1880s because of research. This man right here, Sir Francis Galton, he was a British anthropologist and he discovered fingerprinting system of identification. So just thank him right there. And during the 1880s, two police officers by the names of Juan Vucetich and Sir Edward R. Henry developed the fingerprint systems which they like use today, even except better versions. So that was pretty big too. And right here we have like comparisons. This is two sibling fingerprints, and they look not identical but very similar. Um, and then this is non-related people's fingerprints, and they look completely different for the most part. So yeah. This is the relation to chemistry. Um, there is molecular similarity amongst individual fingerprints, meaning every like fingerprint is basically different and unique in its own way, making it really good for identification. Um, the size of a pattern is equivalent to the number of atoms and bonds the pattern encompasses. So basically, all the patterns are just atoms and bonds, like the amount you have. Like everyone has different amounts, so it makes a different fingerprint. It's pretty cool. Um, Fingerprints are a very abstract representation of certain structural features of a molecule. Um, the fingerprinting process inspects the molecule and produces a pattern for every atom, a pattern representing each atom and its nearest neighbors, including the bonds that join them, a pattern representing each group of atoms and bonds connected by paths up to 2 bonds long, atoms and bonds linked by paths up to 3 bonds in the distance, continuing with paths up to 4, 5, 6, or even 7 bonds in distance. So the fingerprinting process just this really highly relates to chemistry because it's all about the bonds and molecules and how long they are basically making your fingerprints. So it's a pretty good topic for this one. The Latent Print Operations Unit, which is a unit in the Federal Bureau of Investigation, also known as the FBI, and they cautiously examine fingerprints registered from crime scenes, and of course they would do really big crime scenes, so this is very important to have experts really examining these fingerprints. They utilize state-of-the-art tools to find and lift fingerprints at crime scenes. Like they have like a powder you can put like just throw like onto a surface you want to get fingerprints from, and it'll basically highlight all the fingerprints. Or you can use like these certain lights and stuff. It's pretty crazy. Um, they locate, process, preserve, examine, and compare friction ridge impressions, which means the friction ridge impressions, basically like the ridges in your fingerprints. Um, they report discoveries and comparisons of latent fingerprints, palm prints, and footprints. So not only can the FBI like use your fingerprints, but even like your palm print or your footprint, which is pretty crazy. That's really advanced stuff. So um, yeah, it's pretty cool. Um, this is fingerprint summary. Starting in the 1880s, thanks to Sir Francis Galton, fingerprints are very vital to modern day society. People use fingerprints to do ordinary tasks now. For instance, unlocking your phone. They also play a key role in investigation of crimes. With all that originates from fingerprints, they stream countless jobs in civilization, from biometric fingerprinting technicians to the FBI's latent print operations unit, which really lets us know how important fingerprinting is and how vital it is really to today's society. And um, fingerprints really are a big part of uh, everything we do now in society, because you could get caught for doing something if they even find your fingerprint, and we use it a lot, like even for stuff to unlock our phones or just simple stuff like that. So that's my honors chemistry project.